In this video, I'm going to go over the different methods you can use to solve quadratic equations. You can use the complete the square method, factorising, quadratic formula, and you can solve it graphically. But you may not have access to graphical software or graphing paper in the exam, but if you do, you might be asked to show these skills. So if we start with complete the square, we want to get the equation, a quadratic equation, in this form, right? So if we start with this, so what you want to do is you want to rewrite it in this form, but a is exactly half of this coefficient. So I'll do an example. X plus 3 squared, and then you want to minus what's generated in this bracket. So right now, if you were to bracket this out, you would have x squared plus 6x plus 9, right? So we have the x squared, we have the 6x, however we've got minus 5, and here we've got plus 9, right? So we don't want to change the equation, we just want to rearrange it in this form. So once we've done this, notice how my value of a, this value, is exactly half of this value, and that's like what we always want. This is a rule that it's always half. So we've written in the form x plus 3 squared, and we know that 3 squared is 9. So to get rid of this, we minus 9. So now we've got this. We have x squared plus 6x, and we've minus 9 here. We can just add this term in. We also have a negative 5, so we add that in and make it equal 0. We can tidy this up, and that's it. That's how you complete the square. You have it in this form. So if we do another example, we have x plus, now our coefficient of x is 4, so the value of a is going to be 2. And we have that squared. So if we bracket this out, you have x squared plus 4x, because it's x times 2 and 2 times x. And then we have 2 squared, which is 4. So we have x plus 2 squared minus 4, and then we have this minus 1, which makes it equal to 0. Then we have x plus 2, if we tidy it up, minus 5 equals to 0. I want to further explain why you always half it, because this is always a rule. So say we had a plus b squared, right? If we bracket that out, we have a squared plus ab plus ba plus b squared. And in this case, a times b is the same as b times a. In matrices, that's not always the case, but in terms of numbers, it is in this case. So technically we have 2ab plus b squared. So because that's 2 times a multiplied by b, this value is always half of that one. So if we do another example, we have x squared minus 4x equals minus 12 equals 0. So again, we have x minus half of that value, which is 2, minus 2 squared, negative times negative, so minus 2 squared is 4. Now we want to get rid of that 4, and of course we have our minus 12. So if we tidy it up, there we have it. These can easily be solved. If you add 16 to both sides, square root, and plus 2, then you can get x by itself. But we're focused on having it in this form for complete the square. So for this one, we have x, half of this value, -4. -4 squared is 16, so we minus 16, and we add 5. X minus 4 squared minus 11. There we have it. We have 2x squared plus 4x minus 6 equals 0. Now, this one is a bit different to the examples we've done before, because these examples have the coefficient of 1 in front of x squared, whereas this one doesn't, and that changes how you arrange it. So one of the ways to get by this is to pull out a factor from the first two variables. So we know that 2 and 4, we can pull 2 out of both of them by factorising. So you have x squared plus 2. Right? So all I've done is took 2 out of this and this. If you multiply it back out, you can see we still get 2x squared plus 4x minus 6 equals 0. I've just rearranged it. And so now we've pulled 2 out, we can complete the square on this part because it has a coefficient of technically 1. So if we keep everything the same, we have x plus minus that, divide that value by 2 squared. 1 squared is 1, then you minus 1 minus 6. Right? And that's all we've done. So we can multiply it back out to get 2x plus 1 squared minus 2 minus 6 equals 0. Then if we simplify, and that's all we have to do. We can do it with another example. So as you can see, there's a common factor of 3. So if we pull 3 out, we can see if we multiply it back out, we get the exact same as above. So we've just rearranged it by factorising. Now if we complete the square on the middle part, so we've got 3, x, divide this value by 2, minus 1, and then 1 squared, minus 1 squared is 1, minus 1, and then we have the minus 45. We can simplify it by bracketing it out. Minus 3 minus 45 equals 0. And there we have it. So the next one we're going to move on to solve quadratic equations is to factorise. And so this is just to find solutions, quick solutions. So we have x squared minus x minus 2 equals 0. In factorising you usually have 2 brackets. For quadratics you will have 2, but say for cubics you would have 3 solutions. So we want to look at factors of the coefficients that add or subtract so it makes sense. So for this, we want factors of 2 that can add or subtract to make -1. So 2 only has 2 factors, which is 2 and 1. And see how we've got -1, technically -1 times x to get this value. So to get -1 from 1 and 2, you can have +1 minus 2. So the minus 2 is negative. We can always check this by bracketing out. just to make sure we've multiplied everything. So bracketed out, we have x squared minus 2x plus x minus 2. And then if we simplify, we have what we started with. So you basically want to find factors of this value that add or subtract to make the coefficient of this value, which is what we did here. If we look at another example, we have x squared plus 2x minus 3 equals 0. Now 3 is a very small number, so it only has two factors of 3 and 1. Now 3 is negative, so at least one of them has to be negative. However, this value is positive, so we can think that positive 3 minus 1 can give you positive 2, which is our answer. So positive 3 minus 1, because 3 minus 1 equals 2, but then minus 1 times 3 gives you minus 3. So it's finding two factors with the right signs that gets you these coefficients. So if we work on the next one, you have x squared minus 5x plus 6. We'll assume that equals 0. So we can bracket x. Now 6, you can have 6 and 1, or 3 and 2, multiplied to get 6. Now if we think 6 and 1, you can have negative 6 and positive 1. And that's what you can do to get minus 5. However, negative 6, if I write these, negative 6 times 1 is negative 6. So we won't end up with positive 6. So we can't actually use these pairs. However, when we use 3 and 2, we can use negative 3 and negative 2, because negative 3 and negative 2 will minus to get minus 5x, but then negative 3 and negative 2 will times to get positive x, because negative times a negative is a positive. So that's our solution. If you're asked to actually find the solution, because you've written it in this form, the solution would be x equals 2, right? Because you're looking for a value of x, which when it's in this equation gives you a value of 0, and anything times 0 is 0. So to actually find the solution, only one of these brackets needs to equal 0, which is why one solution is 2, but the other solution is 3. Basically, we want to find the value of x, which makes the bracket 0, and 2 minus 2 gives you 0. So if we look at this one, we have x. So factors of 8, we have 4 and 2, and 8 and 1. Now we can look at what minuses and adds to get 6. So straight away we can see 4 plus 2 is 6, right? With 8 and 1, there's no way you can get 6, so that's automatically out. Because 6 is positive and 8 is positive, we can confirm that both of them are positive, right? You can always multiply out to check, but because both of them are positive, and we know 4 plus 2 is 6, and 4 times 2 is 8, then that's our solution. So it can get a bit more complicated if the coefficient of x squared is not 1, but a different number. So you need to find factors of a and c that add or subtract to make b. So this is a little bit more complex, but it can still be done. So we have 3x and an x equals 0. Now we look at the factors of x, of minus 2. So we have basically minus 2 and 1, or 1 and minus 2, but we can figure that out. So we need 3 to be times by a number, but because this multiplies twice, then you need to figure out a way for one of the values to be multiplied by 3 and the other value to multiply by 1, because the coefficient of that is 1, right? And because when these times a number, it's just x, so it adds to this. So if I add 2 here and 1 here, we'll technically get, and assume these are both positive, we'll get 3x squared, which is what we have here, plus 6x, plus 7x, plus 2. Now that's not the right answer, because obviously we don't have this, but you can see how the 3 influences this middle value. So if I rub this out, we need to find the right combination of 2 and 1 in here. So we know that minus 2 is negative, so one of them has to be negative. And we know that 3 times 2 is 6. So we have positive 2 here, right? Because that's positive 2. 3 times positive 2 is 6. Now because it's negative, it's kind of given that the 1 is a minus, but also that we have 5x, right? So 6x minus x gives you 5x. And that's our solution. Like we said above, to find the actual solution you need the value of x that makes the bracket equal 0. It's the exact same for this one. So the value of x you would put in here, and therefore the solution would be 1 over 3. Okay? So 3 times 1 over 3 is 1. 1 minus 1 gives you 0. So 1 over 3 would be the solution, as well as x minus 2. For this one, we have the same thing. We have 2x, right? So we need factors of 5, which only gives us 5 and 1. We can see here that we have 2 and 1 and 5 and 1 to somehow make 9. Now 2 times 5 is 10, so we know those two are going to multiply. And then we have the 1 here. Because 9 is negative, we know that the 5 is negative. And because the minus 5 is negative, we know that the 1 is positive, right? Because plus times minus is minus. We can check that. 2x squared minus 10x plus 1x minus 5, which gives us that. Next one, we have 6x squared plus 5x minus 6 equals 0. So with this, it's a bit more complex, as you can have 6 or 1, but you can also have 2 or 3. So it could look like this. It could also look like this, which makes it a bit more complex, right? So we need to find the factors of 6. So factors of 6 are 6 and 1 and 3 and 2. So we need to figure out which one is the right one to use and which pair is the right one to use to get 5x. Right? So we can use a bit of trial and error to try and get our way there. So if we used 6 and 1 on here, we can do, so we put 6 here and 1 here. We have 6x squared plus 6 plus 6 plus 6. So if they were both positive, we know that's not right, because that doesn't equal this value. Say they were both negative, we know that's automatically wrong, because this is negative as well. So maybe one of them is positive. So can we get 6x minus 6x? That wouldn't be right, because we have a value of x. So we're thinking it's this one, right? Because if we add 3 and 2 into here, then you're going to get values like 12 and 18. which don't fit well with 5x. So we know it's 3x and we know it's 2x on here. So we can have 2 here, 3 here. Now, because one of them has to be positive, because that's a negative x, right? So say we just did it like that. So 3x times 2x is 6x squared. 3x times minus 3 is negative 9x. 2 times 2x is plus 4x. And 2 times negative 3 is negative 6. So we have the negative 6, we have the 6x squared, but this equals minus 5. Because this equals minus 5, we know we've got our signs wrong, right? So our answer is 3x minus 2 multiplied by 3x plus 3. If we multiply that out, we've got 6x squared plus 9x minus 4x minus 6, which gives us this answer. It's a little bit more work as the ones we've done above, and they'll probably be worth more marks as well in an exam. But it's a similar method, but just trial and error with the numbers. This one, 6x squared plus 5x minus 4 equals 0. Same again, we have 6 and 1, or 3 and 2. With this one, we have 4 and 1 and 2 and 2. So we can already think, without drawing all of this, what kind of numbers will go together to get 5. So we could do 6 and 1 for x squared and 4 and 1. But then we get numbers like 24 and 1, or 1 and 6, or 4 and 6, which don't really get to 5x. If we use 3 and 2, we get numbers like 12 and 2, or 3 and 8. Now with 3 and 8, they're linked to 5, right? So we know this could possibly work. As soon as you get to a link with the numbers, it should work. So 6. So 3x, 2x equals 0. Now, we just said 3 and 1 and 2 and 4 to get 3 and 8, which can make 5. So 3 and 1, 2 and 4. Now we know we've got 6x squared minus 3, because you want a plus 8. So we have 6x squared minus 3x plus 8x minus 4, which gives us our answer. So it's a bit more work, but it comes with practice. Another method is to use factorising by difference of two squares. So this is something that you can identify because it's very distinctive. These numbers are always square roots in most cases. So say I was to expand this, you get x squared minus xa plus ax minus a squared. Now in this case, xa is the same as ax, so x squared. And there we have it. So say we have this, we want to factorise it. We automatically know to square root this number. So it's x plus 3, x minus 3, right? Because we proved here that it's always the square of a. And you have plus a and minus a, like we have here. So with this one, it's x plus 4, x minus 4. And again, same thing. So that's just something to spot. It might help in cancelling out, say if you had fractions. The next one we can use is the quadratic formula. So this is quite a large formula. You'll probably be asked to memorise it if you don't have it at hand with you. So we would usually just sub in the coefficients and solve for x. So we have minus b. So in this case, I should probably mention it's ax plus bx plus c equals 0. So that's the form of the quadratic, which you put the values in. So we have minus b. We'll go with one solution first. B squared minus 4 times c over 2a. Right. So one of our solutions is 4.3. The other solution, because it's a quadratic, we have 2, is before the root sign you put a minus. So the other solution is negative 1.18. You'd usually be asked to use the quadratic formula if you can't factorise or if you can't complete the square, because these numbers aren't very nice. So if we do on another example, we have x equals minus, but you see how b in this case is minus as well, so it's actually positive because minus and minus is positive. So you have 3 plus root b squared, so minus 3 squared, which is 9, minus 4 times ac, so 2 times minus 1, over 2a, so 2 times 2, which gives you 1.78. The other solution is negative 0.28. And last example, minus b plus root b squared minus 4 times a times c over 2a minus 1.5, and the other solution is minus 5. Okay. Our last method of solving quadratic equations is by solving them graphically. So this is where you can either plot the graph or use graphical software like Desmos, and you can see the roots because you know the equation. So for the example on the left, we've plotted x squared minus 7x plus 10 equals 0. Now the root is basically where the line touches the x-axis. This is the x-axis. So we can tell we've got two solutions. We have x equals 2 and x equals 5. This is a much quicker way than, say, the quadratic formula, and we can check by factorising. So we have x, factors of 10, we've got 10 and 1, can't make 7, 5 and 2, we can make 7, 5 and 2, because that's positive 10, they're either both positive or both negative. However, negative 7 is negative, so they're both negative, because you get negative 5 and negative 2 to get negative 7. And from here we have the solutions of 2 and 5. Again, if we complete the square, we'll get the same answer, but just with 7 we get 3.5, and then you'd have the square. So it gives you the exact same answer, but it's just for convenience. For the example on the right, notice how it doesn't touch the x-axis. That means there's no solution for this equation. An example to show this is if we use complete the square. So we have x, we always half this value, so minus 3 squared. Minus 3 squared is 9, so we have minus 9, and we add 10 because 10 was there. If we simplify, right, and so, oh sorry, that's positive because minus 9 plus 10 is 1. And then we have x minus 3 squared. We want to get x by itself, so we minus 1 from both sides. Now notice here, when we want to get rid of the square, we square root. And we can't square root a negative number and to have a real solution. So we technically don't have a real solution because you can't square root a negative number. So no, square rooting a negative number opens up a door to complex numbers, which isn't covered in this video. So another way to find out if a quadratic equation has a solution or not. So solutions, no solution. A quick way is to use the discriminant, which is the bit under the square root under the quadratic formula. So it's the b squared minus 4ac bar. And you basically just have to look at which of the equation is satisfied, and it'll tell you how many roots there are. And that's it.